Hello my students of 3rd Prep. Today we are going to have a new lesson which is the slope of the straight line. This lesson we have taken it and we have studied it the previous year. But this year we are going to study it in details. Let us start. The slope of the straight line. You have studied before that the slope of the straight line which passes through 2 points A and B like that in front of you will be denoted by small letter m. So to find the slope of the straight line passing through these 2 points, it will be denoted by small m. What about m? M will be y2 minus y1 over x2 minus x1. And we must say that x2 minus x1 will not be equal to 0, as any number except 0 over 0 will be undefined. Now we want to find the slope of some straight lines. To find the slope of the 2 points 3, 1 and 4 and 2, try to plot them graphically first. 3 and 1, 4 and 2, and join them together. And notice the angle between the straight line and the positive direction of the x-axis. Now let us try to find the slope mathematically. So it is y2 minus y1 over x2 minus x1. Then it is 2 minus 1 over 4 minus 3 to obtain a result as 1. Now you are going to notice that the slope is a positive value. So it makes an acute angle with the positive direction of the x-axis. Then try to find the slope of the 2 points, -1 and 2, and 3 and 0. First, try to plot these 2 points graphically. -1 and 2 and 3 and 0. Join the 2 points together. You are going to notice in this time that the slope of the straight line makes an obtuse angle. Then try to find the slope mathematically. So slope equals y2 minus y1 over x2 minus x1. So it is 0 minus 2 over 3 minus -1 to obtain a result as -2 over 4, which is equal to -1 over 2. Here the slope of the straight line is a negative value. So it makes an obtuse angle with the positive direction of the x-axis. Now you have 2 different types of slopes up till now. One of them will be positive and makes an acute angle. The other is negative and makes an obtuse angle with the positive direction of the x-axis. Now try to find the slope of these 2 points, 3 and 1 and 1 and 1. Try to plot these 2 points graphically. So it is 3 and 1 and 1 and 1. Join these 2 points together. You are going to notice that this straight line is parallel to the x-axis. Then try to find the slope. It is y2 minus y1 over x2 minus x1, which is 1 minus 1 over 1 minus 3, to obtain a result as 0 over -2, which gives 0. Yes, that's correct. When the slope of the straight line equals 0, you are going to notice that the straight line will be parallel to the x-axis. So the slope is 0 and the straight line will be parallel to the x-axis, and this is the 3rd case of the slope of the straight line. Then you are going to notice that when the 2 lines, the straight line and the x-axis are parallel, this will lead us that y1 will be equal to y2 Or in other words, we can say that y1 minus y2 equals 0. Then, can you find the slope of the straight line which passes through the 2 points -2 and 4 and -2 and 1? First, plot them graphically. Draw the 2 axes and try to plot -2 and 4 and -2 and 1. Join the 2 points together. What do you notice? You are going to notice that the straight line will be parallel to the y-axis. So, slope equals y2 minus y1 over x2 minus x1. So, it is 1 minus 4 over -2 minus -2. To obtain a result as -3 over 0. What do you notice? You are going to notice that the denominator equals 0 and -3 over 0 is undefined. So in this case we can say that slope is undefined, so the straight line will be passing through these 2 points parallel to the y-axis. Not only parallel to the y-axis, but also makes an angle of measure 90 degrees with the positive direction of the x-axis. And here we are going to note a very important note which says that when the value of x1 equals x2 or x1 minus x2 equals 0, it means that the straight line will be parallel to the y-axis. Then the slope of the straight line, which makes an angle theta with the positive direction of the x-axis, will be slope equals tan theta. This is another way to find the slope of the straight line. How can you find it? By taking the tan of the angle included between the straight line and the positive direction of the x-axis. So we can say that the slope equals tan theta. Let us have some examples. Find the slope of the straight line, which makes an angle of measure 56 degrees, 12 minutes, 48 seconds with the positive direction of the x-axis. First of all, what about the slope? The slope equals tan theta. It means that the slope will be tan 56 degrees, 12 minutes, 48 seconds. By using your calculators, you are going to find that the value of the slope will be 1.4945. Another example, find the measure of the positive angle that the straight line makes with the x-axis if the slope m equals 1.4865. Look carefully to the problem. The slope equals 1.4865. So you know that where slope is the slope of the straight line. M is the slope of the straight line. So all of you know that m equals tan theta. So tan theta equals 1.4865. Can you now find the value of theta? Yes, by using your calculators, of course. How? Shift tan 1.4865. So measure angle theta will be 56 degrees, 4 minutes and 13 seconds. What about the relation between the slopes of two parallel straight lines? First of all, look at such a graph. If you plot the two axes, the x and the y axes, draw L1 straight line, which makes an angle of measure theta 1 with the positive direction of the x-axis. And try to draw another straight line, L2, which makes an angle of measure theta 2 with the positive direction of the x-axis. These two lines will be parallel. So L1 is parallel to L2. What do you notice? You are going to notice that measure angle theta 1 equals measure angle theta 2, as they are corresponding angles. Since the two angles are equal, then their slopes are equal. So tan theta 1 equals tan theta 2. Then slope of the straight line number 1 equals the slope of the straight line number 2. And here we can say that if the two straight lines are parallel, then their slopes are equal. If F1 equals M2, then L1 parallel to L2. And this is the converse. If the two slopes are equal, then the two straight lines are parallel. And here we can say that if two lines have equal slopes, then the two lines are parallel. Then prove that the straight line passing through the 2 points -3 and -2 and 4 and 5 is parallel to the straight line, which makes an angle of measure 45 degrees with the positive direction of the x-axis. Now you have two straight lines. One passes through the 2 points -3 and -2 and 4 and 5, and the other makes an angle of measure 45 degrees with the positive direction of the x-axis. And I want you to prove that these two straight lines are parallel. To prove that two straight lines parallel, you must prove that their slopes are equal. Then we must find the slope of the first straight line, the slope of the second one, and if they are equal, so the two straight lines are parallel. So let us try to find the slope of the first straight line. So the slope of the first straight line will be denoted by M1. What about M1? Yes, this straight line passes through 2 points, so it is y2 minus y1 over x2 minus x1. Then it is equal to 5 minus -2 over 4 minus -3, which is equal to 7 over 7 to obtain a result as 1. Then the slope of the first straight line will be 1. What about the slope of the second straight line? Yes, it will be denoted by M2. And how can you find it? It makes an angle of measure 45 degrees with the positive direction of the x-axis. So M2 equals tan theta, which is tan 45. What about tan 45? It is equal to 1. In this case, we have noticed that M1 equals M2 equals 1. And in this case, we can say that as the two slopes are equal, then the two straight lines are parallel. Another example, represent graphically the points A, 2 and 3, B, 6 and 2, C, -2 and -2, and D, -2 and 1 in the coordinate plane. Then prove that the figure ABCD is trapezoid. First of all, let us try to represent these 4 points graphically. So plot the 2 axes, the x and the y axes, and try to plot the points A, B, C, and D, and try to join them all together. So you are going to form a trapezoid, but you must prove that this figure is trapezoid. What is a trapezoid? It is a quadrilateral in which 2 opposite sides are parallel. So we must prove here that there are 2 opposite sides parallel. What are you going to notice? You are going to notice that the 2 parallel sides are BC and AD. So you must prove that these two sides are parallel. How can you prove that two sides parallel? If their slopes are equal. So try to find the slope of AD and denote it by M1, which is equal to y2 minus y1 over x2 minus x1. So M1 equals 3 minus 1 over 2 minus negative 2 to obtain a result as 2 over 4, which is 1 over 2. Then slope of AD will be 1 over 2. Now try to find the slope of BC, which is denoted by M2. What about M2? It is y2 minus y1 over x2 minus x1. Try to substitute. So M2 equals 2 minus negative 2 over 6 minus negative 2 to obtain a result as 4 over 8, which is going to be equal 1 over 2. Here you notice that M1 equals M2. In this case, we can say that AD will be parallel to BC. And here we can say that the figure ABCD is a trapezoid. Another example, if the straight line AB is parallel to the y-axis, where A, x and 2, B, 4 and 7, find the value of x. Here you are going to notice that AB is parallel to the y-axis. What are you going to notice? Since the straight line is parallel to the y-axis, it means that x1 equals x2. What about x1? It is x. What about x2? It's 4. So we can say that x equals 4. Let us have another example. If the straight line CD is parallel to the x-axis, where C, 3 and 1, and D is negative 2 and y, then find the value of y. Here you know that since CD is parallel to the x-axis, it means that y1 equals y2. What about y1? It is 1. y2 is y. So here we can say that y equals 1. And since the straight line parallel to the x-axis, so the value of y must be equal to 1. Now, what about the relation between the slopes of two perpendicular straight lines? Take care, there is a big difference between two parallel straight lines whose slopes will be equal and the two perpendicular straight lines. What's the difference? Let us see. Try first to plot two perpendicular straight lines graphically. L1 and L2 are two perpendicular straight lines. L1 makes an angle of measure theta 1 with the positive direction of the x-axis, and L2 makes an angle of measure theta 2 with the positive direction of the x-axis. Here, L1 is perpendicular to L2, and we are going to notice that M1 times M2 equals negative 1. And in this case, we can say that the product of multiplying the slope of two perpendicular straight lines will be equal to negative 1. This is our rule. The product of multiplying the slopes of two perpendicular straight lines will be negative 1. Let us have examples. Prove that the straight line passing through the points 4 and 3 root 3 and the other point is 5 and 2 square root 3 is perpendicular to the straight line which makes with the positive direction of the x-axis an angle of 30 degrees measure. How can you prove that these two straight lines are perpendicular? Yes, that's correct, if the product of their slopes will be -1. So first of all, we must find the slope of the first straight line, which is denoted by M1. So M1 equals y2 minus y1 over x2 minus x1. So it is 2 square root 3 minus 3 square root 3 over 5 minus 4 to obtain a result as negative square root 3. What about the slope of the straight line L2, which is denoted by M2? Yes, to find it, you are going to find the value of tan theta. So it is tan 30. What about tan 30? It is 1 over square root 3. Now, try to find the product of M1 and M2. So M1 multiplied M2 equals negative square root 3 times 1 over square root 3 to obtain a result as -1. What do you notice? You are going to notice that the product of the two slopes of the two straight lines is -1. And in this case, we can say that L1 is perpendicular to L2. Now, let us have some examples. Prove that A, -1 and -1, B, 2 and 3, C, 6 and 0 are vertices of right angle triangle at B. To prove that they are perpendicular, as angle B will be 90. So first of all, we must find slope of AB. It is denoted by M1, which is equal to y2 minus y1 over x2 minus x1, which is equal to 3 minus -1 over 2 minus -1 to obtain a result as 4 over 3. Then what about slope of BC, which is M2? Yes, M2 equals y2 minus y1 over x2 minus x1. Substitute by the points B and C. So it is 0 minus 3 over 6 minus 2 to obtain a result as -3 over 4. Then try to find the product of M1 and M2. So M1 times M2 equals 4 over 3 multiplied by -3 over 4 to obtain a result as -1. Since the product of the slopes equals -1, then we can say that these two straight lines are perpendicular. So we can say that AB is perpendicular to BC. And in this case, we can say that measure angle B equals 90 degrees. Another example, if the straight line L1 passes the points 3 and 1 and 2 and K, and the straight line L2 makes with the positive direction of the x-axis an angle of measure 45 degrees, find the value of K if L1 and L2 are number 1, parallel, number 2, perpendicular. First of all, to find the value of K which makes the two straight lines parallel, let us first find the slope of the two lines. So M1, which is the slope of L1, equals y2 minus y1 over x2 minus x1, which is equal to K minus 1 over 2 minus 3 to obtain a result as K minus 1 over -1. What about the slope of the other line? It is denoted by M2. So M2 equals slope of L2. And we are going to find it from the rule tan theta. So it is tan 45 degrees to obtain a result as 1. To find the value of K if the two straight lines are parallel, Then if L1 is parallel to L2, then M1 equals M2. What about M1? It is K minus 1 over negative 1 equal. What about M2? It is 1. By making cross multiplication, you are going to find that K minus 1 equals negative 1. So the value of K will be 0. So K will be 0 if the two straight lines are parallel. What about if the two straight lines are perpendicular? If L1 is perpendicular to L2, we know that the product of their slopes will be negative 1. So M1 times M2 equals negative 1. What about M1? It is K minus 1 over negative 1 times what about M2? It is 1, which is equal to negative 1. Of course, you are going to find K minus 1 as K minus 1 equals 1. And in this case, we are going to find that K equals 2. So K will be 2 if the two straight lines are perpendicular. Let us have another example. To prove that A, B, C are collinear, you must prove that M1, which is the slope of AB, equals M2, which is the slope of BC, equals M3, which is the slope of AC. So, prove that A, 4 and 3, B, 1 and 1, C, negative 5 and negative 3 are collinear. First of all, try to find slope of AB, which is denoted by M1. How? 1 minus 3 over 1 minus 4. So it is negative 2 over negative 3 to obtain a result as 2 over 3. What about slope of BC? It is denoted by M2. And it is equal to negative 3 minus 1 over negative 5 minus 1 to obtain a result as negative 4 over negative 6, which is reduced to be 2 over 3. What do you notice? You are going to notice that M1 equals M2. And there is a common point, which is B. So we can say that A, B, and C are collinear points. By the end of this example, we have reached the end of our lesson. I wish that I benefit you, and I wish that all of you understood the lesson. Thank you, and bye-bye.